Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the last topic of the electromagnetic radiations, which is the light overview. Basically, we completed the whole unit and we say that if the light is either a particle or a wave. And we do some questions which are related to the photon momentum, which topic we discussed in the previous lesson. And we move on to very particular part, like when we do the momentum and pulse, which we do the long questions like initial. In this, we are going to form in the point of view of the electromagnetic radiations. We do some questions which are very important for the written responses or for the long questions you get in the MCQs or in the written if you want. So let's start with some overview of this unit. I completed that unit. So in this unit, the overarching question was that is the light a wave or a particle? The answer to the question involves the concept of the wave particle durability. We do that topic in the previous lesson, that wave particle durability. Like this, the light is a both, light is a wave and the particle both. Light is both a wave and a particle, which where it comes to play depends on how the observer interacts with it. So, as we have seen in the history of the physics, there has been evidence to support that the light is a particle, and there has been evidence to support that the light is a wave. So, there are both evidences in our history of physics that we have evidence for that the light is a particle. We have evidence for this which support the light is also a wave too. So, the light is particle, light is a wave, both. This is a durability. So it was open like Planck, Einstein, Bohr, Quantum, de Broglie, and many others who had tied together new ideas to tell us that light is a particle and the wave simultaneously. To summarize the table below, evidences we have. So for the light behaving as a particle, we already done these topics, which is the photoelectric effect and the quantum effect. Both are evidence for that the light is a particle. And evidence for the light behaving as a wave is that we do interference, we do diffraction, we do polarization. These all three things tells us that the light behave as a wave. So, like one thing we have to, if you know that, what's the one thing like this is that the light is a wave or a particle, nothing happens. That both we have we have a evidence for both. So this means light is a particle and the wave, both of them. It's durability in that. So that's the we doing that unit for this subject is the light is a wave or particle, and we get the answer from here. So the questions I'm talking about that these type of questions you get when you have like written in examinations and all. So you get these sort of questions which are like you get you the photon momentum. So let's doing that questions and let to know that how can we deal with those type of questions. To determine the magnitude of the momenta of the incident and the scattered photons and the scattered electrons velocity. So the question says an X-ray photon has a wavelength of this collides with the stationary electron. So we have a photon incident X-ray which is going to be like collide with the stationary electron. Scattered X-ray photon, it has a wavelength of this and returns along the initial path. When this X-ray photon incident, when they collide with the stationary electron, they will startle. The photon instead will go scattered and will become the scattered photon, and this stationary electron also being like moved towards like in their direction, which we call the stratal electron. So for this, we have to find the momentum of the instant and the scattered photons. So basically, we have to find the pi and we have to find the ps. We have to find this both. And we also have the wavelengths for both, and we have the formula for this. So if you want, so if you for a part, if you want to find the pi, so we have a wavelength of this h upon wavelength, not the mass times velocity, because we're doing the let photon momentum. So photon momentum, this is the formula for that. And we know that h is equal to 6.63 into 10 raised to minus 34 joules per second. We use that h always in this. And we have 2.0 into 10 raised to minus 10 for instant wavelength. Yeah. So when you solve this, you get about 3.315 into 10 raised to minus 24 kg dot meter per second. So you get this, and this is your pi. For PS, which is scattered proton, so we do h upon wavelength again. So which means PS is equal to 6.63 into 10 raised to minus 34 joules per second, multiply by now 2.049 into 10 raised to power minus 10 meters. When you solve this, you get about 3.236 into, when you solve this, you get about 3.236 into 10 raised to power minus 24 kg dot meter per second. So this is your PS. So you find the both of the things, and this is answer for A. For the B part, we have to find the scattered electrons velocity. So basically, we have to find the electrons velocity which is scattered. Like for this one, the velocity of this. This was the stationary at initial, but what was like when they scattered? So we have found the velocity for that. So which means we have to find the uh, this one, the electrons velocity which is scattered. So that's we have to find. For this type of question, like for this to find, we have to know that what is the momentum of the electron. So we don't have mentioned that any momentum for the electron, so we have to find that. How? So these are colliding. So momentum and impulse, we're doing something like we're talking to this. We're doing the hit and stick method. We do the hit and collisions. So that hit and rebond formula we have to use in this. So all the momentum formulas are coming to this again, and we have to figure it out how can we use in this in terms of the photon momentums. So initially we have a photon momentum plus we have electrons momentum is equal to, then we again have the photon which is now final, so dash again this one which is now E. So we have initial which become incident photon which become our scattered, and electron which become our photon electron now. And so we have to find this. So this is initially at 0. We know this is initially at 0. So we want for PE, which is this, the last one. This is PE. So this PE we have to find. So PE is equal to this one minus this momentum. And this both momentum we already find over there in A part. So put that both in that. So 3.315 into 10 raised to power minus 34 kg dot meter per second minus. Now scattered one is also being negative. Why is it negative? Because when they move light over there, so we take this direction as positive. But when they scatter, they go to the opposite direction, respective direction. This means they go opposite direction, which means we have to take this in negative now. So the scattered photon we take it as negative 3.236 into 10 raised to 1 minus 24 kg dot meter per second. When you solve this, you get PE, the electron momentum is 6.550 into 10 raised to power minus 24 kg dot meter per second. We get this, and we have to find the velocity. Now we use the momentum's formula, which is PE, as we have to find. This is our given. Now we have to find this. So ME, which is the mass of the electron, and this velocity we have to find. So this thing is equal to the PE as upon ME. So this you find 6.550 into 10 raised to power minus 24 kg dot meter per second. This should be divided by the electron's velocity with electron's mass, which is this given in a formula sheet. When you solve this, you get about 7.191 into 10 raised to power 6 meter per second. And this is your velocity for the scattered electron. So that's how you can find. So we use all the things we done in the momentum and impulse. We do the hit and rebound. We do hit and stick. These two things mainly comes. Explosion is not coming in that because explosions are a different way thing. So these two things are probably doing, and more importantly, we do this hit and rebound more in this. and in the also in the two dimensions too. So like in the next question, which is that one, we do the now dimensions, like a two dimension we figure, like components that are involved in this now. So the question says, in the observation of the quantum effect, a photon is incident on a free stationary electron. The stator photon is detected and the stator electron is not shown. Okay, this is the incident photon, this is stationary free electron, and this can be the path of the stator photon. The stator electron is not over there, but we have to find the velocity of that scattered electron and identify the physics principle used in that. So the basically question has given us the wavelength of the path of the incident photon. Stator photon's path will have, we have a momentum of that. We don't have the wavelength for that, and we also have like our angle over there, because at the end we have to find the angle too, and this angle helps us to find something else. Okay, so basically for this, for the scattered electrons velocity which we find, we have to find something. Before starting to the x component, y component individually, we have to find that information we have given to us. So over there, if we make this thing like over there like this goes to right angle triangle. This is our photon's momentum, which is final now. So at y, this is at x, which is again final. So these two things we can find from here, because we have an angle theta over there, 36.4 degrees. We can find by this. So how we can find? We can also have a momentum in this over there. So we can find this. How we can find this? So for this, firstly for x, so we have that momentum which is 1.79 to 10 raised to minus 23 kg per meter per second. This is all we done in the forces and fields in momentum and impulse. We're just doing something else. So we have to find this h, and h is our base. So we're basically doing the base, and we have a hypotenuse which is the cos. So we do cos 36.4 degrees. When you solve this, you get about 1.4407 into 10 raised to power minus 23 kg dot meter per second. We get this. For the next one, it's all over there. For y, we again have same momentum, but now we have to find for the y. For y, we have a perpendicular upon hypotenuse, which is the sine of this now. So this thing, so photon's momentum at y final, we get about 1.0622 into 10 raised to power minus 23 kg dot meter per second. These two things we used in that question, but we have a momentum for this, like we have a momentum for a scattered photon, but we don't have the momentum for the incident photon. We have a wavelength, so we have to be in, like all the things be in the momentum. So we have to find this for momentum 2. To find this, we didn't use this formula, which is 6.63 into 10 raised to minus 34 joules per seconds. Divide this by the wavelength, 40.0 into 10 equals the value of minus 2 10 raised to minus 12. When you solve this, you get about 1.6575 into 10 raised to power minus 23 kg dot meter per second. Now we are ready to do the individual x component, y component to find our resultant vector. So for this, for the x component, this is again the hit and red bond thing. So we use the same thing for x in the electron is equal to the in x for photon, and for the this is for this, like this. So for basically we have to find the velocity. So but this is goes to initial, which is 0. So we left with p r s is equal to, not r, this is a photon. So the photon for x final plus we like open this out, because we want that electron's velocity at x, which is final. So we isolate this thing and we get this minus this divided by mass of electron. So this thing is equal to what? So we have this 1.6575. This we have find over there, and the red we find. So 575 into 10 raised to minus 23 kg dot meter per second. This now be minus with, now minus 1.4407 into 10 raised to power minus 23 kg dot meter per second, and this whole thing be divided by the electron's mass, which is this. And when we solve this, we get about 2.379 into 10 raised to power 6 meter per second. So this is electron mass at x. So this is for the velocity of the electron at x. For y, we do the same thing. For that, we do like y. So photon y plus electron y initially this thing. And then we have like final. This thing again should be inverse. So this goes out. For this thing initially, this PRY, this initially on the x-axis. So they're moving like on the this path. So this path is called the x-axis, and this horizontal thing, vertical thing, we did the like a y-axis. So this is horizontally like this goes like the x-axis. So we take this not be as 0. We take this. So this also goes to 0. So 0 is equal to this, and we open this like this. So we want like v electron's velocity at y. So this is equal to minus of this upon me. So this thing is equal to now minus 1.0622. We already find in the first line, divided by again the mass of the electron we have, and then we find this. We find this about minus 1.165 into 10 raised to power 7 meter per second. We find the both, and the both are in the, this is in positive, this is in negative. So for the resultant vector I've made over there, for the resultant vector, this y thing will go to the, this go to left, they go to north. We take this as north. So if we like go to this thing, we take it as north, and this thing we take it as the east. So east will stay the same. We take the x-axis at the east. So like this goes east, which is our velocity at x. But this to solve because it's negative, so we get the opposite thing now, and we have to find this, which is our VE, and at theta we have to find them. So for the resultant one now, we have a V at x square, V at y square. So this thing is equal to, take the S1, so 2.379 into 10 raised to power 6 meter per second square plus 1.165 into 10 raised to power 7 meter per second square whole root. So when you solve this, you get about 1.190 into 10 raised to power 7 meter per second. And for the angle, we do tan theta is equal to the y, and for the x, for the reverse of this, we do 1.165 into 10 raised to power 7 meter per second, 2.379 into 10 raised to power 6 meter per second. When you solve this, you get the rate of about 78.467 degrees, which is south of east. You know how can you name the angle? So the south of the east. So this is your theta. So as your final answer, you get about 1.19 to 10 raised to power 7 meter per second and 78.5 degrees, which is the south of east. So this is your electron's velocity of the scattered electron velocity. So that's how you can find. And for the physics principle we used in this, we don't like use any of the things in this. So for fourth one, we use at the conservation of momentum in like when we find the x component and y component, we use the physics principle number 4, which is conservation of momentum. And initially when you find this thing, this is the physics principle 9, which is the wave particle durability. The physics principle 9. So we use 9 and 4 or 4 and 9. So this is the answer for that. So that's all what you have to show to like properly doing that questions, and that's systematic what you have to show to get the full marks in that questions. So after that question, we end this unit. So there's nothing to be like explaining all the things, like we explain all the things from this chapter, and this is like big unit and there are so many topics to cover. So that's all have to be covered, and in the next lesson we do some practice question of that part, because we finished the last part of this unit. After we do some diploma questions, then we finally ended that unit. So that's all for this lesson. Learn using EduVibe. Learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till next time, get it with EduVibe.